Cool. Yeah, thanks for coming. Yeah, it's great to be back here today. I met so many of old geek friends and I haven't met for a while. Thomas, one of them. So many. Daniel. So many. Sorry to call your name out here because to show your age here. Yeah, and great to have all the new faces here. And a lot of us from Cake is also coming. Thanks for coming along. So yeah, so 10 years back when at Geekcamp I gave a talk on that's a title of that talk. Wait, before that let me just introduce myself a little bit. So for me, I am a CTO and co-founder of Cake DeFi. I'm an entrepreneur. I'm an engineer. I'm a coder. Co-founder of Cake DeFi with Dr. Julian Haas, the CEO of Cake DeFi. We are the leading DeFi service providers in the world. I've been active in Bitcoin and Ethereum on the technical space, especially since around 2010. And for those of you familiar with Sand Dollar, the world's first central bank digital currency in Bahamas, it's built right here in Singapore. So a lot of the engineers are based here in Singapore that built the first retail CBDC in the world in Bahamas. I'm the architect of that. And a lot of the engineers right now work at Cake DeFi today. Yep, cool. So this is a talk that I gave in 2012, 10 years ago. Anyone here attended the talk, if you remember? You're probably not even primary school or something. Yep, so yeah, 10 years ago I gave this talk on cryptography and trying to tell the audience on how Bitcoin is safer than your bank because of this magic thing called cryptography. And for me, my attitude back then was I was very a libertarian. Like, it's the first time that you get to control this thing called money, that you don't have to rely on any authority to do all that you want to do. And I was a software engineer, and my interest was in cybersecurity. So naturally, when I first heard about Bitcoin, it just drawn me right into that. That's a great use case of cryptography, and you control your own money. You don't have to rely on anyone for money. And I gave this talk in 2012. That was like 2 years after I got into Bitcoin. Built quite a few things since then. Quite a few Bitcoin and blockchain projects since then. I just want to get a gauge. So anyone here who holds Bitcoin who holds any crypto for the last let's say from 2012. Okay, great. How about from 2015? Oh, cool. How about from, I should do it the other way around. Shouldn't be doing this way, so it's kind of weird now. Okay, so never mind, let's continue. So who holds Bitcoin and Ethereum, or who knows about Bitcoin and Ethereum from 2017, so that's 5 years ago. That was at the peak of ICO. Oh, great. Cool. And how about anyone who just first came to know about Bitcoin and Ethereum from around 2020? Okay, that's cool. That's great. How about who hasn't heard or used Bitcoin and Ethereum at all? And this is the first time that you heard about it or used it. I mean, you haven't used it yet, but if you heard about it, okay. All right, so I gave this talk, so largely about cryptography, and yeah, that was me. With a lot more black hair. Yeah, so at one of the slides, Bitcoin was $15, and there was a price at when I gave the talk. So I think I calibrated it one day before my talk, and then I gave the same talk. I think another month back, it was $10 or something. So it was a crash after that. So I just want to make sure that I get the price correct. I actually checked as well when I prepared for this talk. So there's this article from the same time period. So it's written by, look at the author's name, right? Vitalik Buterin. So he was a author of Bitcoin magazine. And so he confirmed that there's a high of Bitcoin price during around my time when I gave that talk. So August 2012 was 15.4. So yeah, you can see that the run up of that price. And before that, there was a crash. I think this was 10 and then it crashed like 2 or something, and then it ran up to 15 when I gave that talk. So if you don't know what's the price of Bitcoin right now, it's 20.6. Yeah, I have it as part of my clock. What's the time now? 20.6K now, o'clock. And this is from my earlier talk as well. I just kind of like, when I revise it, look at the security incidents happened from 2012. Bitcoin worth 228K was stolen from a hacked web wallet back then called, I forgot, Webhost. I don't think that's the name of that wallet, but it was using Linode for that, I remember it. So they left the key on Linode, and the server got hacked, and the keys, all the Bitcoin that all the users were using got stolen. So it's 228K got lost, and then Mt. Gox, massive hack and a sell-off. And then Bitcoinica, which was the first margin site for Bitcoin, got hacked. Bitcoinica was also built right here in Singapore. The guy that built it is called Ryan Zhou. I think he's now based in Australia. Yeah, a lot of innovations happen on the Bitcoin space happen right here in Singapore. So looking at numbers right now, looking at 200K, 460K, sounds like so small now in comparison. I mean, just shocking. Like back then, it was like, wow, it's big money. But back then, the market cap of crypto was way smaller. So just a trivia here when I give this talk. Just a guess. How many times does the word blockchain mentioned in my talk? Anyone? Any guesses? 0? Any guesses? Any other guesses? 2? All right, but that's a giveaway when I throw this question. So it was once. No one guessed it. But it was 2 words. Interestingly, it was 2 words. I was going to spelling it blockchain with 2 words for quite a few years. And then I was the last few that kind of like really combined. I really hated it when it was combining because like it really described what it is. Like it's a chain of block, and it was 2 words. I mean, just a trivia here. Just mentioned once in the talk. Back then it was all just Bitcoin, and no one talked about blockchain. And blockchain is basically to refer to the database of Bitcoin, and it was 2 words. And so I'm gonna give this talk today to kind of like recap for the last 10 years from the evolution of Bitcoin and blockchain for the last 10 years. I'm going to ignore the price stuff. I'm going to ignore all the crashes and all the market stuff because you hear that a lot on news and a lot on, in the media and all that. So let's do it more on the tech side to see how the evolution happens since then. There's a lot to cover, so I'll try to cover as much as possible, but there's still a lot of things that I cannot cram in. Just way too much. It's happened in the last 10 years. Because if you're in the space, you know that people say that a year in like a month in like blockchain time is like 5 years or 10 years in the regular tech space. In tech space, even for that, tech's already way faster than other industries. So on blockchain, it's super fast. So I'm gonna do this format like just to go from the evolution of Bitcoin all the way to where we are today. So I'm gonna ask like, what can we? So it's gonna be this format about. Think about Bitcoin. What can we do more with Bitcoin? So let's throw this idea. So we're going to start with this question. So what can we do with Bitcoin? Can we change some attributes of Bitcoin and come up with new coins here? So this was happened in the early 2010, 2011. So this is how Litecoin came around. It's a Bitcoin fork with a shorter block time. So that's 4 times faster than Bitcoin. Wow, 2.5 minutes, and a different hashing algorithm. And then Peercoin kind of started a proof of stake kind of hashing algorithm, and Feathercoin. The fact that it's called Feathercoin shows how light it was, right? And even faster block time, 1 minute. But if you're going to use a blockchain today of 1 minute, you're going to, oh, that's so slow. I need to wait 1 minute for that. And Ethereum is like 14 seconds or 13 seconds now, and a lot like Solana and all this is like 2 seconds or something. That's super fast. So back then it was really light. And also just a trivia, the creator of Feathercoin, Peter Bushnell, now works at DeFi as the blockchain engineer for Birthday Research, which is our R&D arm at DeFi. I'm going to talk about that later. And so all of that is still cryptocurrency. It's still blockchain. So you're going to tweak some parameters, going to change some hashing algorithm, and then going to ask can we, this thing about blockchain, can we do something else more than just crypto, more than just cryptocurrency? Let's kind of think of what can we do with it. So these are some of the special purpose blockchain that start to come around 2012, 2013 period. So we have this Ripple, which is still around today. So they started this token. It's a blockchain that's 100% pre-mined, so you can't mine new chain. You can't mine new crypto. You just create a blockchain. You assign 100% to yourself, and then you're gonna slowly sell it out. And then it's account-based, so that's different from the UTXO model. Can get a bit technical here, but that's somewhat of a different from Bitcoin because it allows you to have other tokens on the blockchain as well besides the main coin. And dark coin, which kind of like create this idea where the coin itself, the transaction can be anonymous. So if you send money to someone else, you can see that it is correct, but you cannot trace how much the wallet has. So that's kind of like the premise of dark coin, which eventually renamed to be or rebranded to be a Dash today. And Namecoin, it's a very interesting. I'm going to talk a bit more about Namecoin. We're going to talk about Dash first. So dark coin. So around that time, so people start to have ideas about how can we use blockchain to do something else, something more with just crypto. So Darkcoin has this idea about trying to create an anonymous digital currency. So there's two parts of that consensus. One is proof of work, just like how Bitcoin works. If you throw a lot of hash, by chance you're gonna find a block, and that's how kind of like Bitcoin was distributed. And so Darkcoin created like a dual consensus system, proof of work and proof of service. Proof of service is basically a company called a masternode, where the idea behind proof of service is instead of waiting for the block to be mined, which is, I think for Dash is still 10 minutes per block, so it's kind of slow, the masternodes will vote if the transaction is true or not. So it's kind of like a majority thing. So a lot of people, I think there's a lot of misconception, especially among the non-techies when they talk about blockchain. So there's all these masternodes, there's all these miners out there. When there's a transaction happen, what does it validate? Does it mean that the miners are voting to see is this correct, is this valid, or is it not valid? It's not a voting, right? You can validate a transaction yourself by just having the private key and the public key of that, and just validate that the person actually has the money that he's trying to spend. So you do not have to, it's not a voting. But Dash kind of started this voting thing where instead of waiting for the block to be mined, let's get the vote of all the masternodes, so that if there's a majority vote that says that there's a valid one, it's a very high chance it's a valid, so you can take that as a yes, that you can immediately accept as a payment. So they call it InstaSend. And around this time as well, Dash or Darkcoin at the time started this idea called it wasn't called DAO back then, it was just a community fund, where there's this pool of fund where it's set aside for community, for anyone to want to build things on the ecosystem to ask for funding. So these masternodes would then vote again in a similar way. Is that something that the community wants to spend money on, or is it not? Like, so it's kind of voting system. So in a way, it's like a start of DAO, this whole thing. Then Namecoin is very, very interesting. It's a DNS system that is decentralized. So there's this .bit GTLD, global top-level domain. So it's governed by bit DNS, so it's not a ICANN domain. So if you want to use this, then you need to change your DNS to point to bit DNS. So it's the same. So everything else on Namecoin is the same as Bitcoin, but it's a separate blockchain. So the way that it uses that, there's only two more things that is added there. So you can actually burn 0.01 NMC Namecoin to register a domain if it's not taken yet. So if you burn that, then you get your right to own that. And that pays you for the first year. And thereafter, you can then spend another 0.01 to renew your domain for every year after that. So it's a very specific purpose blockchain that was just used to govern domain name. Back then, actually, it was very interesting to me. Like, oh, wow, this is a great use case of blockchain beyond just crypto. And today, we have a similar thing called Ethereum name service. Similar structure, a lot more a lot more sophistication behind it. And Namecoin is still around. I mean, blockchain, it doesn't die. It's still around, but no one uses it anymore. But it's a great idea. Do something more than just crypto on blockchain. I'm going to flash this once in a while, just kind of like put you back in the time when I talk about, so just kind of get an idea. So you get an idea to calibrate yourself on the blockchain or the crypto scene in those days. So in 2013, you can see that Bitcoin's top, obviously, and Litecoin. And number 3 was Namecoin, because it's one of the greatest use case for blockchain back then. Purecoin and the rest are largely fork of, I mean, they're all fork of Bitcoin. So there's no other coins out there that are not forks of Bitcoin. So all of them are forks of Bitcoin. And so the rest are crypto with some tweaks on the parameters and the attributes. And Namecoin, I think among these are the one that actually has a real use case behind it to govern a decentralized DNS. So that was kind of cool. And the market cap, yeah, you can kind of see, yeah, second was Litecoin, still really far behind. The third one is really far behind Litecoin. Yeah, now the next question is being asked. So if you have to start a new blockchain to build things, to run something, can we actually build things on Bitcoin? Any ideas how can we build things on Bitcoin? The funny thing is, okay, before that. So Bitcoin has this thing called a Bitcoin script. So it's this language or a script where you can kind of program things, but it's non-Turing complete. So you can write any application to run on it. That's only very specific set of instruction that you can put on a Bitcoin script, and for you to write a certain kind of limited smart contract to do things. So for that, it's called opcode. Just like your, I think, a computing system, there's an instruction set, so there's like also like opcode. And so it's for things like multisig. If you want to create a contract where you need like 3 out of 5 person to sign, so you can use the opcode to do that. If you want to create a time lock where you lock in a certain amount of Bitcoin that your kid can only spend, I know, 10 years later, you can do that on Bitcoin using this Bitcoin script. And hash lock, spend conditions, you need like certain condition to be met before you can spend those money and how much you can spend. So you can define all of that in Bitcoin script, but you can't write like a game or casinos on Bitcoin script because it's very limited set of instructions, non-Turing complete. So this is an idea about how Bitcoin script is run. So it's basically stack-based, right? Just like your actual machine. So all these are very instructions. So these are just the opcodes on Bitcoin script. So this is just a very simple example of a regular Bitcoin transaction. So when you send Bitcoin to someone, it's a one-to-one transaction. So this is what goes behind it. So the first part, when you send someone a Bitcoin, you will specify the amount and the address that you send someone. So I'm going to go through this roughly just because it's Geekcamp, and I guess we can all follow through along on this one. So it's actually quite straightforward. So when you send someone Bitcoin, you specify the address and then the amount. So and then you're going to sign with your own address to say that I authorize my spending to send to you. So the signature will go in front. So you can actually see, after this, you can actually go through the big blockchain explorer. You can see all of this stack actually in there, all this instruction in there. This is the most simple set of Bitcoin spend. So you're going to sign that you want to send, and then you're going to put in a public key of your own. Of your own. You're going to sign. So the signature here is actually including the, it's part of the. It has the destination address and has the amount to spend. So this is the part where you kind of unlock that you allow this to go through. So you're going to reveal your public key. So the public key of Bitcoin address is actually not the address of yourself. So back then, all Bitcoin address was just starting with 1. So very simple pay to script hash kind of address start with 1. And that's not a public key. The address is actually a hash. I think it's hash of a hash of public key. So when you spend your Bitcoin, you actually reveal your public key, but it's not a critical thing. The private key is the critical thing. But whenever you spend something, you actually reveal public key. Otherwise, it's just an address. Address is just a hash of a public key, so it's a two different thing. So you need to reveal a public key for the first time and then duplicate. So I'm going to roughly go through this, and then a hash that, and then okay, let me go through that right now. So okay, let's start. So let's go through the SIG. So you're gonna put the SIG on the first stack. The second step, you're gonna also include the public key, put in the stack. Next one you're gonna duplicate. So you're gonna duplicate the stack to public key. The next one is the hash. So you're gonna hash the public key to turn into a public key hash. And after that, you will also put in the hash of the wait, let me try to refresh it a little bit. So after you hash it, and then this is the one you're gonna put on top, and then the equal verifies to make sure that they match. Otherwise, this will return false, and then it will fail. And once you verify, it takes off the slash because it's true. And then the next thing is you're gonna do a that you left with pub key and sign. So the check SIG is basically checking the signature against the public key to see whether it's valid or not. If it's valid, then it's true, and then the transaction goes through. So this is what happens when you spend a Bitcoin, when you send Bitcoin to someone. Yeah, so this is what happens after that. So you want to build something on Bitcoin, right? So can we attach a token on Bitcoin? So there's this, just like any programming language, so there's this return on the opcode where if you process something, you can return true and that just exit everything. So anything that goes after that is ignored, right? Just like your programming language, any program that you use. So on Bitcoin side, there's similar things called OP return. So if that's return true or return, you just have OP return, everything else after that is ignored. So which means that you can actually attach metadata behind that on the Bitcoin transaction to do something else. But that is not parsed by the Bitcoin blockchain. So it's completely ignored by Bitcoin blockchain. So what this allows is then the developers back then to start having ideas about what can we build on that? What can we use that limited space for? So let's have our own way to attach some metadata. Like you could see people writing like random message on Bitcoin back then after OP return, and you can see people like putting their marriage vows on Bitcoin back then. It was like still, you can see a lot of that on Bitcoin. Yeah, and so this idea about having colored coin is to have tokens on the Bitcoin blockchain to have all this metadata after the OP return. So the two of the largest protocols back then was Counterparty and Omni. Any one of you heard of Counterparty? Any of you heard of Omni? In a few seconds, you're gonna hear about Omni. So because if you have used crypto for the last 5 years or so, you have used Omni, just you don't know it. So I just wanna, I have some of these boxes in part of my slides, kind of like pose a question to kind of for us to think through as well. So if we attach metadata on a Bitcoin that way, what kind of a UX does it look like? So because the Bitcoin is kind of ignored, this metadata is kind of ignored on the Bitcoin side. So if you send something else to someone, Bitcoin cannot validate whether it's true or false. So anything that you send has to go through because Bitcoin only validates the part before OP return. So if you do this thing, you're gonna have to have your own client. So Counterparty and Omni have their own client that runs on top of a Bitcoin node to validate. So basically on their part, they ignore whatever that's before OP return, whereas Bitcoin node validates whatever that's before. And Counterparty and Omni only checks whatever that's after that. So there's a header to say that it's Counterparty message after that, it's Omni message after that. So they will then see, so there's all this instruction. I'm gonna send like 5 SGD or whatever. It's just a token, right? So you're gonna say, I send 5 SGD to someone else. And all this, even if you don't have that 5 SGD, it will go through on Bitcoin blockchain because Bitcoin doesn't validate that. So the client on the Counterparty and Omni has to validate that. So they have to check whether this address has the amount that they claim they have and all of that. And the UX, another issue of the UX is that if you want to send a token to someone else, you're going to need Bitcoin to push that message across, right? Because even though it's SGD token, for example, you cannot use that to pay for the miner to include your block in the blockchain because that token is ignored by the Bitcoin blockchain, is ignored by the Bitcoin miners, so no one can accept that token. So it's just a metadata after that. So which also means that you'll fill, I mean that blockchain, if you try to parse the omni metadata on the Bitcoin blockchain, you're gonna see a lot of false transactions. People are just trying, oh, I just send $1 million HUD to someone else. I don't know if Bitcoin will accept that as a valid block, but it's the omni protocol that has to make sure that that's valid or not. So, yep. So that's a problem about doing this on a Bitcoin blockchain. But it was kind of interesting back then. So you can build a lot of things on. You can build like tokens on Bitcoin blockchain back then. And now that we have tokens, we have crypto. Then the next thing that natural people ask is, how can we have a token of crypto that's zero volatility? You know where I'm heading next, I guess, with this question, the stablecoin, right? So stablecoin in 2014, Tether, widely known as ERC20 token today, but back then, 2014, it was an Omni token. So it was an Omni token on a Bitcoin blockchain. So a stablecoin backed by US dollar issued by this Tether, an organization in the US that they have $1 in the vault before they issue a token. So if you have that stablecoin, you can go to the office and say, I want to redeem that stablecoin for $1 in the vault, so I'm going to pass you that. So therefore, the price of that token is stable, therefore it's called stablecoin. So how was it like before Tether USD? Tether, there's no stablecoin before that. So it's just crypto all around, floating up and down all the time. And stablecoins today, the model has actually evolved quite a lot. We have seen a lot more models of stablecoin. We have seen DAI, where it's backed by crypto. We've seen USD is backed by crypto. And so we also seen algorithmic coin as well. There's like there's some parameters and algorithm that kind of make sure that it's pegged to $1 without actually having anything that's backing or some collateral that's backing it. So there's a lot more evolvement has seen on the stablecoin side. But back then, it's all about having the $1 in the vault, having something to back whatever that token that you issue. So that's what we call stablecoin back then. Yeah. So the next question then, once you have stablecoin, also like how can we as a developer, as a coder, build stuff on blockchain? Now that we have all these tokens, can we build actual applications of blockchain with all I don't know, like with the limited set of space that we have? So back then the answer was you can't build anything on the blockchain because it's just crypto, it's just token. Just like you don't build apps on USD, just like you don't build apps on fiat, you transact. So you build an e-commerce site, you transact on USD, you transact on Bitcoin, you transact on crypto, on the tokens. So you don't really build apps on the blockchain itself. So this is site and services back then. Yeah, so Silk Road, the famous one. When I gave that talk, I think at that time, Bitcoin was widely associated with Silk Road back then. So I know people viewing me back then, like I'm associated with this. No, and Mt. Gox was one of the largest exchanges back then. And for people like me who has some funds at Mt. Gox, we're going to get our fund back in coming January, I think. It's been I've been waiting for a long time for this. I'm one of the creators of Mt. Gox. We're only getting, I think, about 20% back, so still something. The price of Bitcoin has gone up, so yeah. The legal team has taken all the funds, so when Mt. Gox was insolvent, the fund that was left in the balance sheet was less than the amount that they owe, obviously. But the price of Bitcoin has gone up so much, so it could actually pay back dollar value. But the legal process and all that took so long, and I've been getting mails every 1.5 years or so, thick stack of mail coming from Japan. Most of them in Japanese, I can't read. Only like the last few pages are translated in English, and there's a disclaimer that says this is a translated version. It's not a legal version, just for information on what all the top part is about. So all that I'm pretty sure costs money and all that. So, and I'm not the only one in the world that's the creditor. So I'm pretty sure that that's how much all this thing is going to cost. So these are site and services back then. So you don't really build on the blockchain itself. You build something and then you transact on the blockchain. And there's this thing that started to come up as well. called provably fair gaming, which I really like about it. Not so much the gaming part, but it's a great concept that I think blockchain kind of started, where if you go to if you play a slot machine in a casino or something, like how do you know that the machine is not rigged? So there's this. So that's how we have the authority to make sure that the machine has to pay out 95% of the money that they take over a certain period of time, and they can check that the algorithm is true. But for the first time, you can actually do that on the website. If you use any online website, you play an online game, how can you be sure that that's fair, right? You can't be sure, because if you pull a slot machine on an online casino, how can you know that's fair? So this allows a very fair roll of dice. A very you can verify for yourself that the roll of dice and the roll of slot machines and all that are actually mandated by the blockchain that was completely random. I know there's some talks that you can kind of like influence it as well if you control a certain amount of miners, but that's a different topic. But it's an idea where the randomness can actually be proven by a blockchain. There's nothing that the site can do to influence the randomness of that you're going to get. And this was widely popular back then. And to the point where I do remember that time where if you look into a Bitcoin blockchain, if you look at the mempool, almost all the transactions are on Satoshi dice. People are just sending funds to Satoshi dice all the time. It's filled with all the Satoshi dice transactions around this period of time. Look at mempool is super fast. Almost all of it ends on the similar addresses. It's dominating all the mempool. Yeah, so those are cool. Like you build stuff and you transact on the blockchain and you use it for monetary transactions. But can we really build things directly on blockchain? This is a question that's being asked a lot by developer community. So, yeah, what do we do with it? Maybe a world computer. Like, can we do something on the blockchain? Is there any value in doing something like that? Maybe a world computer that we can build something that everyone in the world see the same thing and we can all run the same thing. So let's define what do you mean by a world computer? Let's just put this back in 2015. So what does it mean? What does it do? And what does it need? So what does it mean a world computer? So a world computer kind of means that it needs to be global. Like everyone should see the same state of that machine. It's just one computer that everyone should see the same state. It's a singleton. If the state of that variable is 5 over here in Singapore, it should be 5 over in the US. So it should be exactly the same. So no one should see the two different things. So if I increment by 1 in Singapore, it should be incremented by 1 in the US as well. So that's singleton. And programmable. You can program anything on this world computer. And the coding is Turing complete. Open execution. For the first time, you can verify in a computer that the program that's running that computer is doing exactly what it claims it does. Like if you have even on open source side, if I download open source code and run on my Mac, for example, I can rig my Mac to run it differently, even from the source code that I download, because I can change the way that it parses the execution code. But for the first time with world computer, you can validate that the open execution part is true, so you can trust it 100% that it's not rigged. And atomicity is also another great value of world computer, because if you're gonna have something that goes through on one side, doesn't go through on the other side, and a failed transaction doesn't alter any of the state. So if a failed transaction should reject and then doesn't change any of the state. So that's the atomicity part. So all these are key USP or key ideas that started this whole thing called Ethereum that we have. So Ethereum is a virtual machine. This is one single virtual machine in the world that has these opcodes that really mimics what you see in your computer today. Like it's just you can see this as assembly instruction sets. So there's a stop, add, multiply. So you don't see things like what we see on the Bitcoin side, where it's more like hash and all that. I mean, there's hash as well, but you don't see things like limited set of things only to validate addresses. It's more of a very generic set of instructions where you can build anything and everything that you want. You can build a game there if you want, if there's no limit on the instruction computation side. So this is what the premise of Ethereum, when it first started in 2015. I think they start to play lower now on the premise of that it's a world computer, because I think that's playing too much on the developer side, because we get it, world computer, but people outside of our community don't really get world computer. What's world computer? What's that? Again, so this historical snapshot, 2015. So Bitcoin number 1, XRP number 2, 3.8 billion on Bitcoin market cap. Litecoin, Ethereum starting to come up. Ethereum come up really, really fast. So when it first announced, when it first launched, it's quite widely taken up already. And a lot of developer tools started to come up around that time when it was first announced. Even before it was the first, what? 5 minutes left? Is that for me? Oh, wow. Okay, now I gotta speed up. Okay, thanks. All right, cool. All right, yeah. Okay, now we have all this. What do we build? Okay, I'm gonna speed up a little bit. So there's a lot of libraries and tools to dev that were built around the time, and IoT. Slockit is one, a great example, where you can link opening of a lock with a Ethereum transaction. So this IoT, but IoT part is a little bit tricky. It's a little bit why do you need blockchain for that? I mean, because the last mile is still off of blockchain. So why do you need blockchain for that? But then you can build a lot of simple games. You can build on-chain chess and decentralized publishing. That's kind of the vibe where we get when we get the first time that we can build decentralized apps on a blockchain. So that's what we all built back then. And tokenization starts to also take place now, because we now have a standard. I mean, before that, there wasn't a standard, but people just build token on the decentralized app, and around July 2015, where we start to have standard that since a lot of these apps are going to have tokens, so let's have a standard to do that. And there's a token standard called ERC20. And the funny thing is, it took Tether another two and a half years to launch ERC20 version of USDT. So USDT that's popular today, ERC20 version today, was only started in 2018. So before that, if you use USDT, which was the largest stablecoin back then, you have to interact with Omni protocol. And it's such a pain, because I built so many systems for us running a software company to do a lot of blockchain development. So some of them include USDT, and you have to deal on the Omni protocol on Bitcoin side. It's a lot of pain. Once Tether moved to ERC20, it's so much easier. And historical snapshot, 2016. One thing that's missing here, clearly, is the missing of Tether, stablecoin, over in this. You can see Ethereum Classic. So this is after the DAO hack has happened, so Ethereum has forked to Ethereum Classic. But still, what's glaringly missing is the stablecoin. So once we build all this token, it comes back, let's raise some funds for this token. So initial coin offering is kind of the theme. In 2016, 2017, raise some funds, sell some tokens. A lot of these tokens are sold before even the product was built, even before the prototypes were built. So, and then there's this comparison between ICO and VC, and a lot of speculation that says ICO is the way to go moving forward, and VC is kind of like the old way of raising funds, so you should go ICO. I mean, today it's completely flipped now, I think. And can tokens be unique? So a lot of these questions are then asked, right? So this what happens with NFT. NFT, it started from around 2017 with, I think CryptoPunks was the first one. I know about it, but I'm like, oh, what can you do with it? I didn't pay much attention to it, but it's quite an interesting idea. And as CryptoKitties, I thought that was the first time. It's quite interesting. What I like about CryptoKitties a lot more than CryptoPunks is that the breeding part of CryptoKitties is completely smart contract driven. So if you breed one kitty to another, what you get out of that is completely an outcome of that smart contract. So it's completely on chain. That's super cool. I love so much about that. Yeah, I started from 2017. There's a down wave of NFT after that, and then boom again like last year or so. So I got a snapshot 2017, still glaringly missing Tether. Yeah, so all along for the last 10 years of blockchain, of Bitcoin, there is no stablecoin. There's no real use of stablecoin but for now, it's a very surprising thought for a lot of people, because we take stablecoins as one of the biggest thing and one of the things that we take for granted on the blockchain. It's surprising to think that for the first 10 years of blockchain, there's no stablecoin. Everything is just floating around. And then the next thing is, does finance have to always be off-chain? Then DeFi came along, decentralized finance. So this is the first kind of a decentralized finance use case. The on-chain exchange called Ether Delta. So the first thing that you would do on chain is definitely you're going to build something that you have on the off-chain side. So you're going to clone an exchange and put it on chain. It's called Ether Delta. So generally took off. Anyone knows? Anyone want to take a guess on why? Yeah, hard to use. Yeah, hard to use is it's a great answer. I was expect some of you would say it's expensive. Kept one network. Okay, now it's multi-network, but at that time everything was Ethereum. But you can redo multiple ERC20s even on Ether Delta. Yeah, back then there was no other networks to Ethereum. Everything else is super tiny. But then expensive is also not the key problem because everything was so really cheap on Ethereum. Back then transaction fee was not a problem, but the key problem was the clunkiness of having to change your order book all the time. You want to change your price, you need to submit transaction, you need to wait 15 seconds for it to confirm. So the UX is really, really horrible. And then came around Uniswap, where this automated market maker trading, where instead of having to wait for someone to do a match with your order, you just participate in a pool, add liquidity, and it just goes through. You don't have to wait. Liquidity money, if you're a liquidity provider, you're gonna get rewarded from that, and you don't have to wait. You don't have to change the price for order book because the AMM algorithm automatically change it for you. If you want to do a swap, it's instant. You don't have to do anything. So this completely changed everything. And then that brings up to the next step for more DeFi. So we have Maker that creates a new kind of stablecoin called DAI. It's crypto backed, and we have similar thing on Terra Luna and UST as well. It's not backed by Terra. It's not backed by Terra, but the algorithm makes it you can swap UST to Terra, and vice versa. And we know how that goes later on. But yeah, but this comes up with a whole new evolution of DeFi, and that's also another idea about can we make DeFi secure as Bitcoin on a non-chain complete system. So I'm involved in this project. So DeFiChain is where all these DeFi transactions happen on Bitcoin-style opcodes. So instead of having build it on a Turing complete system, you come up with opcodes that only do specific things that's needed to do DeFi. So you have like DAC, loan, Oracle, auction, atomic swap, and all that done with a limited set of instructions and opcodes. This is very, very similar to Bitcoin that we all love and used to for the first couple of years. So we are doing the same style here with DeFi. And historical snapshot 2019. Surprise, surprise, still no USDT here in 2019. So there's only like, oh, it's there now, number 8. Okay, yeah, for the first number 8. Okay, yeah, thank you. Thank you for that. Yeah. Okay, now can we play games on chain? But yes, but blockchain is so slow. I'm gonna rush through it. Give me another 5 minutes, please. Okay. All right. Okay, but blockchain is so slow because you play a game. If you submit everything on blockchain, it's just so slow. You need to wait for it to confirm. Even 40 minutes is way too slow. If you want to make a move on a metaverse or on a MMO, you're gonna have to wait 40 minutes for it to make a step, right? This is way too slow. So, but what does it really mean? What do we really need to be on chain, and why? What does on chain even mean here? So, why not on chain? So on chain is slow. It's expensive now. Back then it wasn't, but now it's expensive. If you want to put anything on the blockchain, it's slow, it's expensive, and it is challenging because you need to sign transactions all the time. You can have a system that signs it for you, but it's always still challenging to build that. But why? Okay, why not off? Wait, what's so why on chain? Why to build on chain? Because it has a strong guarantee to the game mechanics. So everyone is sure that that's completely fair. If you draw a raffle on the on-chain system, you know that's completely fair. If you go on let's say a World of Warcraft, you join a raffle, you don't know if it's completely fair or not because that's running on a Blizzard server, so you don't know if it's fair. But if it's on-chain, you know it's fair. So there's a very strong guarantee. It's completely trustless. And Paul Grau, which I built a Ethereum tool, and Paul Grau also contributed to my project so back then. So he built this chess game. I think this was back in 2016. Yeah, 2016. He built this chess game on chain. As one of the things that I found out is that even though Ethereum Virtual Machine is Turing complete, you can build anything that you want, but you should not be doing that because you don't need it to be completely on chain. So next comes the next part where it's really big today, layer 2. So layer 2 is where you have the computation done on the second layer above the blockchain itself. So what is payment? Just gonna throw a quick question. So what is payment? Why do we need blockchain? So payment itself, if you break it down to the most fundamental level, it's just about sending money from one wallet to another. So for that, you just need public key infrastructure. You just need PKI. You don't need anything else. You just, if I sign my transaction to you, you can verify that I sign my check to you. You can also see that I have that money because you can check the database and you can take that check. But why do we need blockchain for that? Because we can send money to each other, right? The blockchain part comes in because of global singleton state machine to prevent double spend. So and that's where blockchain is important. So I'm going to skim through a lot of this thing because I actually prepared quite a bit on Lightning Network, but unfortunately we don't have time here. So layer 2, it's a very key thing on Lightning Network. It's one of the first things that started layer 2 on the Bitcoin blockchain. So the basic on how it works is that if you want to send money to someone very frequently, you're going to open a payment channel off of the blockchain, and then you're going to keep sending. Let's say I open a payment channel. I'm going to subscribe to Singtel, for example, $100 over the next 6 months. I'm going to send every month. I'm going to send 30. I'm going to deduct $30 from here and then send 70 back to myself all the time. And we don't need to put it on chain, so that's saved on transaction fees with the providers. So eventually, you're going to settle after that. So the way that it works is to maintain that no parties can cheat through. I wanted to go through this, but I'm going to skip through that right now. So the idea is you start with this amount. You're going to send more and more to Bob, and then in return to yourself, you're going to reduce your return. But there's some game system where what if someone published the earlier check and then falsely claim your earlier one? So there's penalty system that built in as well on Lightning Network to prevent that. And that's just a small part of the whole Lightning Network. It's a whole lot bigger than that. Because routing, there's a P2P network, there's a pathfinding system. You got to deal with all the transports and all the fees, because sometimes you may need to jump through multiple nodes to get to your destination, because you might not have payment channel open directly with your recipient. So all of that is part of that. And on layer 2 on Ethereum, there's a very similar thing as well, but more on the state machine part. So yeah, so this is some of the large projects on layer 2 on Ethereum. And yeah, this is where we are today. Yeah, Tether now is number 3. Very interesting. Bitcoin, Ethereum, BNB, USDC now, another stablecoin, number 5. Yeah, so with that, I'm going to just pose a very simple question. What's next on a blockchain? I think there's a lot of things to still be built on this. And a lot of things that actually already happened as well. I wanted to, when I put down the notes on when I want to cover for this talk, I actually put down the notes for each one of these as well, but just way too much. Even for that, I can't even have enough time right now. But it's a lot of great things to be built on the blockchain part. This all on the tech side, nothing to do with the hype, with the money, with all the Lambo, with all the stuff that's going on there. Let's leave all of that. We're all developers. Let's build great things here. This is what I love about blockchain. We can build great things here and really change the world with it. And before I end this, I just want to talk quickly about Cake DeFi. So we have a research arm called Birthday Research. Yeah, there's a team over there, researchers and developers over there. So it's called Birthday Research because our birthday problem. I want to talk to that, so I don't have time now. Can look at the birthday problem. It's one of the key things. If you deal with cryptography, it's a thing that you always think about to make sure that it doesn't clash. Basically, just in a room of like here, what's the likelihood of us having the same birthday? It's very, very high. Actually, maybe 70% here, or maybe 80% here that we have. No, I would say it's like maybe 90% they have clashing of birthday. So yeah, we have a lot of open roles. We're hiring developers. We're hiring engineers in JavaScript, TypeScript, Rust, C++. So if you're interested to join us, please do come to our website. And for all of you here, please do carry on, build, and we're gonna do great things on blockchain. There's a lot more things to be done here. Thank you very much.